Good day, everyone. Today we will be discussing some important facts on different elements. These facts consist of the physical and chemical properties, as well as vital uses of each element. We will also be covering a few compounds that are commonly used in everyday life. For this chapter, we will be covering the essential facts on oxygen, ozone, hydrogen, water, hydrogen peroxide, nitrogen, and ammonia. Stay tuned because there will be more videos with a wider range of elements to cover. Oxygen. Oxygen is a colorless, tasteless, odorless gas that is heavier than air. It can be cooled into a liquid at negative 118.82 degrees Celsius and solidified at negative 218.4 degrees Celsius. It is primarily used as an oxidizing agent, as well as a major component in combustion reactions. Oxidizing agents are elements that gain electrons. At high temperatures, oxygen can react with silicon, boron, arsenic, and nitrogen. Oxygen is responsible for the changes in paint, fats, oils, rubber, fabric, and leather. These items, when exposed to oxygen, will result in an oxidation reaction, causing the mentioned items to change color. Oxygen is a vital element needed by human beings. Severe deprivation of oxygen can have detrimental effects in the human body and ultimately death. In the industry, oxygen is stored in green cylinders that contain not less than 99% concentration of oxygen. These massive amounts of the element can be used in steel fabrication, steel industry, and industrial maintenance. It is commonly used in medical practice as a form of relief for pneumonia, angina, asthma, cyanosis, and dyspnea. It is also used to treat chloroform, coal gas, or nitrous oxide poisoning. It is also used in the resuscitation of people who drowned. It is also stored in places of low oxygen, such as planes and submarines. Liquid oxygen is used to treat growth, such as warts or lesions. Ozone. Ozone takes the form of a bluish gas with a peculiar and irritating odor. It can be liquefied with a blue color at negative 180 degrees Celsius and freezed at negative 250 degrees Celsius. Unlike oxygen, ozone can oxidize metals like mercury and silver at normal temperatures. It is known to be a strong oxidizing agent, exceeding that of atomic oxygen. Liquid ozone is also hazardous as it is highly explosive. Ozone is rarely used in the industry, as acute exposure can cause headaches and dry throat. Hydrogen. Hydrogen is a colorless, tasteless, and odorless gas. It is lighter than air and can be liquefied at negative 239.9 degrees Celsius with a pressure of 12.8 atmospheres. It can also be made into a colorless solid below negative 259.14 degrees Celsius. Hydrogen is normally inactive at normal temperatures. At high temperatures, hydrogen is a strong reducing agent, which means it loses electrons. Hydrogen burns in air with a pale blue, non-luminous flame. When mixed with oxygen, it will produce an oxyhydrogen flame with a temperature over 2,500 degrees Celsius, capable of melting all metals. Hydrogen is used in the Haber process for nitrogen fixation. This process is used when inflating balloons. This Haber process is also used to make high temperatures with oxygen and the hydrogenation of oils. Water. Pure water is a tasteless, odorless, and colorless liquid. It is greenish-blue in large quantities. It exists as a liquid between 0 degrees Celsius to 100 degrees Celsius. Below 0 degrees, it is a solid ice, and above 100 degrees Celsius, it's a vapor. Water is a poor conductor of heat and electricity. Natural waters tend to contain sediments such as dirt, silt, and rust, which can be removed via filtration or coagulation. Natural waters also contain bacteria that can be removed by various methods such as chlorination. Lastly, natural waters contain dissolved ions such as sodium, potassium, calcium, magnesium, iron, strontium, barium, etc. In most chemical reactions, water plays a mechanical role in chemical reactions. It is a stable substance that combines with many oxides to form acids and bases. It can break down substances like aluminum, lead, arsenic, antimony, bismuth, and manganese into smaller components, a process known as hydrolysis. Hydrogen peroxide. Hydrogen peroxide is an unstable, colorless, and syrupy liquid with a boiling point of 62.8 degrees Celsius. It decomposes slowly under normal temperatures. In contrast to its decomposition above 100 degrees Celsius, it explodes violently to form water and oxygen. Hydrogen peroxide can also be cooled at 10 degrees Celsius to form colorless, transparent crystals that melt at -1.7 degrees Celsius. In the presence of high-purity substances, hydrogen peroxide becomes stable. Otherwise, it will decompose into water and oxygen. This decomposition can release heat, which is very slow without a catalyst. Contaminants such as dust and dirt can catalyze this decomposition and release heat. Despite the reactiveness of hydrogen peroxide, there are stabilizers created to prevent unwanted reactions. There are three types: acidic complex forming, adsorptive. All acids, albeit organic or inorganic, can stabilize hydrogen peroxide. Complex forming stabilizers act as screening agents that prevent hydrogen peroxide from reacting with light. Adsorptive stabilizers are designed to remove impurities in hydrogen peroxide solutions. 30% hydrogen peroxide solutions, vapors, are considered caustic or can cause burns, corrosion to tissues and organs. Ingestion of solutions, 3% of hydrogen peroxide must be avoided to prevent irritation and bleeding. Vapors can irritate the nose and eyes. Direct contact of liquid solutions to the skin may result in a stinging sensation. Nitrogen. Nitrogen is a tasteless, odorless, and colorless gas. It can be transformed into a liquid at -147.3 degrees Celsius at 33.49 atmospheres. It can also be solidified at -209.8 degrees Celsius. Nitrogen is an inert gas, meaning it will not engage in chemical reactions. It also does not burn or support combustion reactions. However, it can be activated by high-voltage discharges. At high temperatures, it can react with lithium, boron, barium, calcium, strontium, and magnesium to form nitrides. Nitrogen is also combined with halogens, such as chlorine and iodine, to form nitrogen trichloride and nitrogen triiodine, respectively. The former of which is a volatile, oily, and yellow substance that contains a pungent odor and explosive properties. The latter is also an explosive substance. Nitrogen is stored in blue-pink cylinders. Their main pharmaceutical use is an oxidation retardant in the identity test for carbon monoxide. They are also used to produce an inert atmosphere for organic chemical reactions. Substances like cod liver oil, olive oil, and castor oil are packaged with a nitrogen atmosphere to prevent oxidation. This retardation of oxidation is required so that the oxygen atoms will not alter the structure and function of the oil. This chemical, in liquid form, is also used to administer a freezing treatment. It can reach up to -195.556 degrees Celsius to treat warts, angiomas, etc. It can also be used to freeze gums, waxes, rubbers, and resins, an essential part in the processing operations to prevent their sticky properties from interfering. Ammonia. Ammonia is a colorless gas with a pungent odor. It is about half as heavy as air and can be liquefied in two different ways. Expose it to temperatures of -60 degrees Celsius or expose it to -10 degrees Celsius and 6 to 7 atmospheres of pressure. Liquid ammonia boils at -33.35 Celsius, and the white crystals of solid ammonia melt at -77.7 degrees. Contrary to popular belief, ammonia is stable at low temperatures. It decomposes to hydrogen and nitrogen at high temperatures or by an electric spark. Such a reaction can be reversed. Ammonia can react with active chemical groups similar to water. This reaction allows it to form ammonia basic salts. Ammonia is used mostly in the production of various essential compounds. It is also used as a fertilizer and is directly applied to soil. Additionally, it is the starting point in the production of a wide range of military explosives. Liquid ammonia is used for refrigeration and is used to make artificial ice. Finally, ammonia also contains medical applications such as the preparation of antacids, counter-irritants, stimulants, salt and soap formations, and basic properties. That's it for part 1 of our series on essential facts of different elements. Stay tuned for more videos where we will be covering other groups such as the halogens, alkali metals, alkali earth metals, transition metals, and other non-metals. Check out our other social media profiles and our Patreon for more content. Thank you for listening.